Today we're going to talk about geometric sequences and series. So last time we talked about arithmetic where we had a common difference. Geometric behaves a little bit differently, and I put 3 examples here. So 1, 3, 9, 27, 5, negative 10, 20, negative 40, and then 1, 1/2, 1/4, 1/8. So what you should see there is we are multiplying to get to the next term. So here I'm multiplying by 3 to get to the next term. Here I'm multiplying by a -2. So it alternates between positive and negative numbers. Here I'm multiplying by 1/2. Okay, so a geometric sequence is a sequence in which each term after the first is the product of the previous term and a common ratio. So with arithmetic, we have a common difference. With geometric, we have a common ratio. And we're going to use R as our formula here. R is going to equal any term divided by the previous term. Okay, so using some notation, that would be AN over the term right before that. So just like with arithmetic, we want to come up with a formula for finding the nth term. So again, I'm going to generate that. So if I have A1 is just A1. To get to the next term, we're going to multiply by the common ratio. So that's going to be A1 times R. Okay, and we're going to keep multiplying by R. So I'm going to multiply by another R. So this would be A1R squared. We'd multiply A1R squared times another R, which gives me A1R cubed. And we see a pattern here. So my nth term is going to be A1 times R to an exponent that's 1 less than the term I want. So R to the n minus 1. So again, the nth term of a geometric sequence is AN is equal to A1 times R to the n minus 1. So if I want to find the next 3 terms in the sequence, 27, 135, 675, and so on, I need to find my common ratio, which is going to be any term divided by the previous term. So if I do 135 divided by 27, we get 5. If I do 675 divided by 135, I'll also get 5. So we're just going to keep multiplying by 5. So if I multiply 675 by 5, we're going to get 3375. Next is 16,875, and then 84375. Okay, so find the 14th term of this one. That's kind of messy. It's just a 1/3, 1/9, and so on. Okay, so using my nth term formula, which is AN equals A1R to the n minus 1, A14 is going to equal 1 times our common ratio, which in this case is 1/3, because that's what we're multiplying, to the 14 minus 1. So that's going to be 1 times 1 to the 13th and 3 to the 13th. So I'm going to go ahead and rewrite this like that. Because if I do 1/3 times to the 13th, I'm going to get a really small decimal. But we'd like it to look like our fractions here. So if I do 3 to the 13th, we get that big number. But that is our 14th term. If we keep multiplying by 1/3, that's what we end up with. So geometric means are terms in between non-consecutive terms of a geometric sequence, just like arithmetic was in between arithmetic terms. Okay, so our next example, form a sequence that has 2 geometric means between 1, 3, 6 and 459. So I've got 136, some number, and 459. So this is A1, A2, A3, and A4. Okay, so I need to find the common ratio. So I'm going to use my nth term formula. Okay, and I'm going to plug in my specifics here. So my 459 is equal to 136, r, which I'm trying to find, to the 4 minus 1. Okay, if I divide 459 over 136, okay, and then I'm going to raise this to the 1/3 power. So 459 to the 1/3 power to get rid of that third power. Type that in the calculator, you're going to get 1.5 or 3/2. So then I can write my series. So we're going to have 136. If I multiply that by 1.5 or 3/2, we get 204. Again, gives me 306. And again, gives me 459. So a geometric series is the sum of the terms of a geometric sequence. So all series are just sums. So geometric is the sum of a geometric sequence. Okay. So again, I'm going to derive this formula for you. This one's a little bit less obvious, but I want you to see where everything comes from. So we're going to have Sn is equal to A1 plus A1r plus A1r squared, and so on down to A1r to the n minus 1. Okay, to get this formula, we're going to multiply this whole row by r. So if I multiply A1 times r, I have A1r. So I'm going to shift that, A1r. If I multiply this by r, I get A1 r squared, and so on. Okay, and then if I multiply this one by one more r, we're going to have A1r to the n. For this one, we are going to subtract. So I'm going to have Sn minus Rsn is equal to A1 minus 0. This minus this goes away, this minus this goes away, all the way and down 0 minus that. Okay, so now I want a formula for just Sn. So I'm going to factor Sn out, which leaves me with that. And you can factor the A1 out. I typically don't, but you can. So to get Sn, I'm going to divide. So the sum is A1 minus A1r squared over 1 minus r. So again, I derived this one for you just so you see why is this so funny? Why are we dividing by 1 minus r? Just where all the different pieces come from. So the sum of a, and there's a word in here, finite geometric series is Sn equals A1 minus A1r to the n over 1 minus r. That reason finite is in there because soon we will be talking about infinite geometric series. So we will get into that later, but that term finite is in there for a specific reason. Okay, so our last example here, find the sum of the first 8 terms of 3 minus 6 plus 12 minus 24, and so on. So my r is -2. So S8 is going to equal A1 minus A1 r to the n, which will be 8, over 1 minus a -2. And you can type all of that into your calculator. Be careful not to simplify. I'll see people go like 3 minus 3, well, that's 0. No, orders of operation, you have to raise it to the power, then multiply, then subtract. But this one we will get negative 2, 5, 5 as our answer. So that is geometric sequences and series.